Okay, so good afternoon to all the students. Uh, as the our first steam turbine. So here we start our final lecture now because previously I gave some introduction about the steam boiler, steam turbine, and whatever the other units involved in this particular subject. Okay, so this documents which is I'm going to present here for the lecture full 113 slide is there and all I send in the group. As well as I also share some videos and YouTube videos. You go through that and if there is any query after doing that video, then you can ask me. Okay. So as you see the steam boiler here in the diagram, we can able to see this is the assembly of our flow diagram of the steam boiler. What happens here is this is the boiler feed water pump. Means feed water pump is what happens. Uh, this pump is used for feeding the water into the turbine. Okay, so this is the main system. Steam head means steam is collected here. Okay, and this is the heating unit. Steam tap, contains return line, and condenser. So whatever the use of the elements, we learn one by one. We learn one by one. So first of all, if we want to see what is the steam boiler. Okay, so steam boiler is nothing but it is a device by which we can generate the steam or produce the steam. We can generate the steam or produce the steam. Okay, so next thing we can see here, what is the definition of the steam boiler? So first and very simple definition for the steam boiler is a closed vessel in which steam is produced. A closed vessel in which steam is produced from water by consumption of the fuel. Okay, the simple definition. So this is not the definition of the boiler, but this is the definition of a steam generator, a device by which we can generate the steam. Okay, so what is that? A closed vessel in which steam is produced by consumption of the fuel. Okay, okay. So what is the other definition of the steam? Well, it is a closed pressure vessel and inside this vessel any liquid or water heated by another heated source and convert this liquid or water to steam. Now, generated steam, when used for another purpose which is outside from the main vessel, it is called the boiler. Okay. So, what is the meaning? The meaning is closed vessel is needed for the steam generation, becoming a boiler. Okay. We generate steam and collect the steam, and after that we can utilize that steam in different applications Okay, so the meaning is first important thing you generate the steam. Okay, so you heard about the type of power plant is your thermal power plant, hydraulic power plant, and the nuclear power plant. Okay, the thermal power plant is based on the steam. Okay, the thermal power plant is based on the steam. We can use coal as a fuel for the boiler, and from the coal we can fire up the coal and generate the steam with the help of boiler. Okay, as picture you see in this picture, what happened? The see here, the water tube boiler is here. The water tube boiler, because see, this is the tube and inside the tube water is here. Okay, water is there. So outside fire is there. So water tube means the tube inside the oh, sorry, the water inside the tube, and fire tube is the fire inside the tube. Okay, my voice is breaking. Just okay. Now my voice is clear. All the students, please be clear. I am audible to all or not? Just reply in the chat box. Student, okay. So the main aim to show this picture, this is a steam boiler, water tube steam boiler. Okay. So in the water tube steam boiler, what happens? Fire is outside the tube and inside water is there. So the efficiency is good as compared to fire tube boiler. Okay. So next, what is the purpose of the boiler? Okay, or we can say that what is the use of the boiler? Okay, for generating the power in the steam or steam turbine. For generating the power from steam engine or steam turbine. Okay, in textile industry, for sizing and bleaching. Okay, so the textile market is also there where we can use the steam for the sizing and bleaching of the cloth. For heating the buildings in the cold weather and for producing hot water for hot water supply. Okay, so these are the some use of steam. So what is primary requirements of a boiler? What is primary requirements of a boiler? The water must be contained safely. Means we have to store water safely. Okay. The system must be safely delivered in the desired condition as required its pressure, temperature, quality, and required rate. Okay. So the steam deliver must in the desired condition. Which uh, in the further lecture, we know the type of steam like a wet steam and dry steam and superheated steam. Okay, dry steam, wet steam and superheated steam. So what type of this type of steam needed, we can supply that type of steam for as per the application. Okay, so what is the boiler term? Okay, boiler term means the name or nomenclature of boiler components means this type of different components is used in the boiler. So it is the terms of the boiler. First cell. Okay, what is the cell? Consists of one or more steam cells built into a cylindrical form and related or welded together. The shell ended at the close with the end plate. So what is the cell? I will show you. So this is the cell. See, the blue color is blue color show the shell of the boiler. Okay. So what is the next part? Setting. Okay. What is that? The primary function of setting is to confine heat to the boiler and form a passage for gases. It is made of bricks work and may form the wall of the furnace and combustion chamber. The combustion chamber where fuel is burned. Okay. Now in this diagram, two different types of, see, this is the water tube boiler and this is the fire tube boiler. Okay. First one is the water tube boiler and second one is fire tube boiler. See, the coal is there, hot coal is there. So hot gases is produced and it pass through the tube. Which is pass through the tube. Okay. And water is surrounded to this tube and steam is generated and where steam out is there. So steam out whatever the steam is generated, we can collect in the separate container from out of the steam. And now here what you can see, this is the boiler open, steam outlet is here. See, here steam outlet is here and see the water inlet is there. So water inlet is there and 1, 2, 3, 3, 4, 5 water tubes you can see here and this is the furnace. Okay. And here this is the combustion chamber. Okay. Air and fuel inlet means inside you can insert the fuel as well as air inside the combustion chamber and we ignite the fuel to generate the heat. Okay, so hot gases is produced and whatever the water traveling through this tube gets steam and we can collect that steam in a separate container or we can supply this steam where it's required. Okay, so here we can easily see what is the difference, how distinctly work water tube boiler and fire tube boiler is here. Okay, this is the fire and fire inside the tube and this is the water. If water inside the tube, so that is your water tube boiler and this is the fire tube boiler. Okay, so now I'm going to show you some small video where you can see the proper working of the steam boiler.
In this video, we are going to discover what an industrial boiler is and how it works. But first, let us consider the term heat. Heat is vital in everyone's day-to-day lives. Whether it be heat to warm up our surroundings or heat to be able to cook food, We all use it to some extent in our day-to-day activities. Water and steam are great heat carriers and are not damaging to our environment. The boiling point of water at atmospheric pressure is 100 degrees centigrade, or 212 degrees Fahrenheit. By pressurizing the boiling system, by giving it an airtight seal, we can actually increase the boiling point. This is how pressure cookers work. An airtight vessel to increase the pressure, to increase the boiling point. This makes the food cook in a much shorter time than if an open saucepan were to be used. So how does this compare with an industrial boiler? Well, for a start, industrial boilers can cope with pressures much higher than a pressure cooker. Industrial boilers are often made by welding together thick steel plates, allowing extremely high pressures to be made. It has to be made incredibly strong to cope with the high pressure, as failure to do so will result in forces close to an exploding bomb. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications. The function of a boiler is to either produce hot water or steam. Hot water boilers heat water for the purpose of domestic or commercial heating and hot water supply. Steam boilers generate steam in order to power turbines for power generation and various other industrial heating applications. To visualize the effects of steam generation using a boiler, think of the steam powering a turbine. When the steam passes through the blades of a turbine, the force turns the blades and accelerates the turbine. Steam contains an enormous amount of energy, so it makes the turbine quite efficient and, depending on the fuel used to boil the water, quite energy efficient too. There are different types of boilers for all sorts of different applications. We are going to cover a couple of the different types, including how each of the methods is able to generate heat, so you can familiarize yourself and be able to correctly identify them. Firstly, fire tube boilers. The typical makeup of this type of boiler is a furnace, a water tank acting as a boiler, and a smokestack. There are tubes running through the water tank carrying the heat from the furnace, and the smokestack vents the heat and gases caused by the heating effect so that the pressure does not continue to rise above the intended level. So, the fuel is burned inside the furnace. The tubes transfer the heat of the furnace through the water in the tank. Once it is heated, the steam generated is moved along downstream. Fire tube boilers tend to be the cheapest type of boiler to produce, as they have a fairly simple construction, but are typically limited for low to medium pressure applications due to the thickness of the outer shell containing the water. Now that we've covered the fire tube boiler, let's have a look at a water tube boiler. The design is fairly similar to a fire tube boiler, but instead of the furnace heating fire tubes to heat water in a tank, the furnace heats water tubes inside the furnace. In the same way, a fuel source is burned in the furnace, causing the water tubes inside to heat up. Once again, when the water is boiled, steam is generated and moved downstream. A water tube boiler is more thermally efficient than a fire tube boiler, but they are more complex to construct, and the quality of the water can be a limiting factor. The water may need filtering to operate most effectively. Combustion is the process of burning a fuel source. To create a reaction, there must be a fuel source, heat, and an oxidizing agent. Boilers can be designed to burn a specific fuel using any number of different technologies, but the main component to consider here is the heat source, or otherwise known as the fuel. The fuel is one of the most important aspects of a boiler, and is what burns inside the boiler to generate the heat. There are many different sources that can be used. Coal is a standard fuel source. In industrial boiler applications, the coal tends to be ground to a fine powder, as it burns more completely than traditional bricks. Electric can be used as a heat source, either by resistance heating coils or electrode units. Electric would normally only be used for smaller commercial or domestic use. Electrode-type applications require very high water quality and conductivity to work effectively. Maintenance is key to electrode-type applications too, as cleaning the insulators is required to prevent arcing between the electrodes.